Uh, Good morning once again, and welcome to the next class. Now our topic is open loop system. Then we will go for the uh, block diagram of automatic control system. Okay, so first open loop control system, and just I want to say that uh, for your automation study is or instrumentation study, past, present, and future, you have to face this type of question: closed loop system and open loop system. You have to know what is the block diagram of representation. May any problem or any phenomenon will be given, you have to represent it. Okay, so any physical system which does not automatically controlled hold, for the variation of its output, it is called as the open loop system. First, any physical system, any physical system which automatically look, it is represented as just like a input. This is your input, this is your controller, and this is your process, and this is your output. This is the only open loop system, but here you can't find any feedback path is there. Okay, so the output control is not controlled after taking feedback. Okay, it is in initial time, it is just control the flow of output, flow of input, and it is go as it is. Say I am giving you some example, you can understand. Say your bread toaster, normal bread toaster, the toaster machine. Okay, you put some bread over here. First day you are putting some 100 degrees centigrade and set the time for the 5 second. You don't know after 5 second what it will be. The after the result, as a result, after 5 second, it may be burnout. Okay, next time you are putting, this is set, this is case one. Now this is case two. Say you are putting, yes, something is you have to fixed over there. uh, yes, this is 100 degrees centigrade, but you put the set point time as the 2 second. What will be the result? Your result may be just white, no brownish spot is there, and it is just like a raw material, just like it will not burn, and it is not cooked, not cooked, not cooked. Okay, so then you have to decide it. Yes, whenever I put some 100 degree centigrade for the 5 second, then it will be brown or the black, maybe burn out. Okay, but if we put 2 seconds it will become raw, non-cooked. So then you automatically put this as a 100 degree centigrade. It set the time for the 3 second. Look, as a result, it may be say it is perfectly cooked. So this is you you don't know what will be the output after process is completed. Then you can get this result, and this result or the status of output is not given to the controller so that it can control. This type of example is given for the open loop control system because we don't know these things. So after whenever you know that is 100 degree centigrade for the one bread for the you have to put some 3 seconds, then you can get the perfect cooking. So then you can apply this for the next time, and it is going on. Okay, so this is called open loop control. And another example, say this is your automated irrigation cases. In your automated irrigation, first time there is some sprinkler is there. In past time some sprinkler is there, means you can see some sprinkler which will spread some water from this tank, and it will timely at the morning in this controller. Here is the controller is there. Our controller is just doing the morning at the 4 a.m. and the evening at the 4 p.m. It will start this valve. It will start this valve so that it can sprinkling over here or your field. But it will not consider any rain if at the 2 p.m. there is a heavy rain. Okay, and it will set for the 1 hour. Okay, so heavy rain is there, it will the field became muddy, but as the controller was controlled for the timing and it will spread some water, then it will be sprinkling over there. So what happens? Your plant will going to die. It may be happens it will give a sprinkling water for the 4 a.m. and the 4 p.m. But in your 30 days, it is no rain is there, so it is highly drought area. It's become highly drought. Temperature is high, but it will start only. This is timing because no controller is acting only on and off. There is no feedback from this your field or this your soil where whatever it is the moisture is, whatever the humidity is. Okay, so this is a open loop control. Say if I put some control system block diagram representation, then we have to put some here, some input is there, controller is there, and there is no comparator is there. Comparator means this type of summation sense. Controller is there and process is there. Okay, so it is going on, but this open loop system can be changed into a closed loop system. Say if I put some humidity sensor, if I put some humidity sensor, say this is a humidity sensor mounted on this field, and it will give some feedback to this controller. Then what happens? Humidity sensor can your program will be just like that, or your algorithm will be just like that. If humidity is the 80%, then we no need of water. Okay, if humidity is 60%, in two times water means 4 a.m. for the 1 hour, and 4, say I'm giving you this climate and 1 hour. If humidity is 40%, then it will be 3 times. Say this is 4 a.m., 2 p.m. and this 4 p.m. Or you may expand this time, maybe it is 6 p.m. If the humidity is 20% means water content in the soil. I am giving the in the example of water content in the soil. That is sense also in humidity sensor. Okay, and then it will run this time 4 times, say 4 a.m., 2 p.m., 6 and 8 p.m. Okay, so then it will start its controlling system. Then yes, your water tank is over there, and here is your controller is there, and here is mounted your, it will sense the humidity or water content in soil. It will give the feedback to the controller, and then controller will decide to on off the valve, whether it is on or off for the flow of water. This is water flow is there, sprinkler is there, water is flowing, or it may be deep irrigation system. Now your modern irrigation system is depending on this drip or irrigation system. For your Israel, for Australia, there is this type of automated irrigation system is going on. So prior to this innovation of this humidity sensor, means say 20 years ago or 15 years ago, no humidity sensor was applied. Then only this is open loop control system was done. But nowadays the automatic control system is over here, because in this automatic system, look, the what will be the control strategy or the block diagram representation. There is a input, there is the input is only water there over here, and here is a comparator, here is a feedback, here is the on off valve, on or off valve or your relay, and here is your process, and this is your feedback. So I think you can get the idea of open loop control system. This is your open loop control system, and this is your closed loop control system. So this type of open loop and closed loop systems are there in process control as well as in your controls theory. So we have to know some theoretical expression of this closed loop control system and open loop control system. What are the features of the closed loop and the open loop control system? Look, again I am drawing this diagram. All the time you have to remember this. What is this? This is input. Okay, anything input, it may be electrical energy, it may be flow of water, it may be flow of temperature, whatever may be, just we have to give the input. Okay, then it is called the comparator or the summer, whatever may be. Or it is given another name, this is called error detector, but this symbol is given as the comparator or the summer. This is called the error detector. Then it will come here, and this is called the control element. This is called controlled element or control element, not control. either controlled element or control element. What are it may be? It may be a on off valve, on off is to ITC switch, etc. etc. And this total item is considered as a controller. This is under the consideration of this controller. So you can see the what are the representation of this controller. Then it will go to here and you can see here is the process. Here is the process. Okay, here is the process and it will be the controlled output. Output coming over here and it is coming here as a feedback. Okay, it may be sensing element. Sensing element. Okay, so this is a representation of closed loop system. Okay, now how could I determine this? There is some features is there. First feature, it is closed loop system. What are the feature? An error detector, error detector compares a signal obtained through okay. So this comparator compares the input and what is the difference between input and what is the present status of this process. Okay, so if say I need 80° centigrade as a set point, this is called the set point, means what I required, but at the process value is means process value is just like a 70° centigrade. So we need we need again there is a difference of 10° centigrade. So some it has to create some signal for the 10° centigrade, or it has to open the channel up to it will reach uh, up to it will reach 80 degrees, so that this error, this difference should be 10 to 0. Okay, so this is the function of this comparator in the controller. Okay, and Now in any difference between these two signals, between any difference between these two signals, it continues it constitute an error signal, or you may say actuating signal, which actu actuates the control elements. Means till it will reach zero, it has to actuate some signal. Means control elements should be open, and whenever it will reach zero, then it will close this control switch. Okay, then another features is there. Look, the control elements in the turn other condition in the plant means controlled number is such a manner as to reduce the original error. Okay, means it goes to the 1 to the 0 state or 0 to the 1 state, so that at in such a manner that it will reduce the original error. Means if there is a 80 degree centigrade, then it will change to first, this is the 70 degree centigrade, then till it will run. Okay, but whenever it's just try to change 80 degree to 80 degree, so there is no error is there, then totally it will this off. Okay, so it will just off in this manner. And so you have to minimize the error so that it will not reach up to 81 degree centigrade. Okay, so it will suddenly it will going to the off, so that it minimize the other organizational error. Okay, or the system error. If it will there is a valve positioner is less, there is so many valve is there, butterfly valve, on off valve, pin valve is there. If this this is giving some error, then you have to adjust so that this controller can reach, whenever it will reach 80 degree, it will suddenly go the off, so that other elements should not be be going to the error cases. This is the main control system. And now we have to know the some features of the open loop system. So guys, I think you can understand these things. This is all about your closed loop control system. And sometime it is asked, give me an example of open loop system with a block diagram representation. Sometime it will be asked to give an example of the closed loop system with block diagram, or sometime it will ask what are the difference between control closed loop control and the open loop control. Okay, then you have to know both of these. So this type of question from very past, present, and future, all time this type of question, any of these question, and will be asked to you. Okay, so that's why you have to know. And if you go for your industry, then you can see if you visit any industry where some process is going on, you can see there is something is there, open loop control circle type, some plan is there. You through watching this plan you can't understand, but whenever someone explain it through this plan, through this control, everything was given, how the process is going on. Okay, that's why it was very important. Now for open loop system. And what is the definition? Any physical system which does not automatically correct for a variation in its output is called as open loop system. Okay, any physical system okay, so what is the representation? That is input, that is controller, okay, the output remains constant. Input signal. Okay, in this system the output remained constant for the constant input system, so output wouldn't change. Means if you give some 100 degrees centigrade, maybe your for the 5 minutes it's your bread became black, or your biscuit may be black. Do you know in your biscuit factory there is some heat treatment is there, so that your color of this biscuit getting rich is what are the desired position. If it is white, then you say that is the biscuit is not cooked, but it should have give a brownish color. If something heat became higher, then your biscuit may be just black and burned. Okay, then it will not be uh, delivered for the process. So your output became static as per the input. Output will not change in this case. But in your regarding to the closed loop control, if you change your input, then your output also change. But here open loop control system, you don't change this as per the time cycling, because once you set this 100 degree centigrade 5, it will the process is going on till the power is your system is not off. Okay, and then next is the input signal in null condition or look, the output may be changed to any desired value by appropriately changing the input signal. Only you can change the input signal, but no other means. But any variation in the external condition or the internal parameter of the system may change the output to vary from the desired level in an uncontrolled manner. Say you are putting 100 degree centigrade for the 5 minutes, but somehow here something is coming. I mean, maybe temperature is outside a atmosphere temperature became increased. Okay, say when it was say this is a very long process. So whenever it was started, then it was the ambient temperature was 20 degree, but after few seconds the ambient temperature may be 30 degree by some hazardous area or by some any change. So what happens is maybe this 100 degree centigrade for 5 times for the 5 time hours, or the process will be perfect, but due to the external change and the process output became imperfect, but it is not controlled by this controller in the open loop controller. But if it was the closed loop controller, then and then it will sense and give the feedback to this. then automatically it will reduce the temperature and reduce the time, so that your process output became static. Okay, so any internal change or any external change will not be controlled by this open loop control system. So this is the the drawbacks of this control system. And guys, this is all about open loop system. There is sometimes a question is given, and what are the open loop system and what are the closed loop system, given difference or comparison. So you have to give minimum is three special characteristics. First one is, this is only changed by the input. Process output is vary only depends on the input. No other control or the mid time control is available over here. But your closed loop control, anytime it will be control and control the input, so that it can reach the output level. Okay, in open loop control system there is no feedback systems is there, but in closed loop system feedback control system, feedback loops is there. And in your last point, in this system that depends on operating condition. If this operating open loop condition, if it is operating condition was changed, then output also change. But in your closed loop path there is nothing is dependent, because if this temperature will change, it will reduce this temperature by taking this feedback. So closed loop system is independent of the external or internal any other parameters variation. So this is the all about your open loop and control system. And if you have any question, you may ask me. Otherwise, your time is only 1 minute, more than 1 minute. Okay, thank you guys. If you don't have any question, I'm going to stop here. Okay.
Thank you, sir.
Thank you. Have a nice day.
Thank you, sir.
Have a nice day.